Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello guys, I am Dhiraj and I welcome you all to Testbook.com, and I'm here to provide you the best I have. So guys, today we are going to do what, my dear, mock test on UPPSC for mechanical, right? So before starting session, let me check that how many people have joined. So I can see that few people have already joined. So guys, those who have already joined, they have to do hit like, share, and subscribe the channel. And my dear, one more thing you have to do, that is what you have to share the link of this video in your social media group so that the maximum people will get joined and they will get benefited of it, right? So I can see that few people have already joined. So all of you are most welcome. And my dear, very good morning to all of you. Very good morning. So it's a mock test, okay? And it's a mock test based on what, my dear? Mechanical, okay? Mechanical. And there should be technical, total technical, okay? So guys, it's right now it's 10:58. Let's wait for 2 minutes and then we'll start the session, okay? Then we'll start the session. I can see that few people have already joined. Hi Satish, you are most welcome in the session. And guys, you can mark your attendance by hitting on a like button. Okay. Abhit, very good morning. A very good morning to all of you. Those who are watching. Very good morning. Very good morning. So, yes, am I audible to all of you? My voice is clear to you? Yes, guys. Okay, so right now it's 10:59. Let's wait for 1 minute, and at sharp 11 we are going to start the session and we're going to end as well. Okay, okay, my dear. So, okay. So those who have joined first time, that I want to let you know, my dear, that is offer for Testbook Pass is going on. That is what offer for the month, and that is you are getting the Testbook Pass just for rupees 299. And my dear, one more thing that I want to tell you, in that you will get 100 plus courses free of cost and 12,000 tests, which include banking, technical, non-technical, teaching. Every examination has been included in this pass. That is one single pass for multiple examinations. And my dear, there is SSC JE Mechanical live coaching batch is running now. So if you are interested in SSC JE Mechanical live coaching, then my dear, please fill the form which is provided in the description of this video. And my dear, I want to tell you that is Gate Reward quiz is going on. You can attempt this quiz in the website of Testbook as well as, my dear, in the app of Testbook. And if you don't have app, my dear, you can download the app from the Google Play Store. And one more thing that I want to add, that is what here supposed to be your score is good, my dear, in quiz, then you have to be rewarded with some exciting prizes, right? So my dear, this is all about the offers and opportunities for you guys provided by the testbook.com. Okay. So my dear, right now it's 11:01. So here we are going to start the session. Very good morning to all of you. Very good morning. So here, this is the first question on your screen. So this is the first question on your screen, my dear. Okay. So here, the first question on your screen. Look at this. Okay. Thermal efficiency of Otto cycle can be represented. Thermal efficiency of Otto cycle can be represented by 1 minus TA by TB. Which of the following statement are correct? Okay, isentropic compression will start from point B. Okay, let me. It is Otto cycle in PV diagram. PV diagram mein na, I A, B, C, D, right? So isentropic compression will start from point B. Because you know that it's nothing but what, my dear? 1 upon compression ratio raised to power gamma minus 1. Am I right now? Yes. V1 by V2. Yes or no? Yes or no, my dear? It is isentropic compression. So you know that what, my dear? V1 by V2, that is what? VA by VB is equal to what, my dear? Is nothing but what? Compression ratio. Okay. I hope you got it. Here I go, my dear. Listen to me very carefully. So now you can see, my dear, that is isentropic compression process will start from B. No, it is start from A only. Isentropic compression will end at point A. No. Constant volume heat addition will start from B. Yes. It is what? Constant volume heat addition. It is constant volume heat rejection. So option number 3 is correct. I hope everybody got it. Very good. Here I go. Here I go. Here I go. It's not. Third is correct. Third is correct. It's not 2. Here I go for next, my dear. 1 meter cube of gas at 5 hours is compressed at constant temperature 2.5 meter cube. What will be the final volume? It is what? Constant temperature. So it should be this one. That, sorry, PV is equal to C is there, right? That means P1 V1 is equal to P2 V2. Just apply it, my dear. You'll get what? Pressure. You'll get P2, and V2 you know that it is 0.5. V1 you know that 0.1. P1 you know that 5. You'll get P2, and that will come around 10 bar. Kitna aega? 10 bar. Here we go for next. Liquids have no specific heat, different values of specific heat at same temperature, only one value of specific heat. It is have only one value of specific heat. Why? Because they are incompressible, solid and liquid. They have only one value of specific heats. Remember, but gases have two. Okay, everybody. Here we go. A boiler accessory that is used to put off the fire in the furnace of the boiler when the water level in the boiler falls below a safe level and prevent overheating of tubes. That is none other than what, my dear? Fusible plug. And which wire is that one? That is made up of lead, fusible plug, right? Fusible plug. Okay, very, you guys are most welcome. Very good, Shivani. Third one. Fusible plug. Here I go for next. What is the main characteristic of the quasi-static process? Quasi means what? Quasi means, I already told you, quasi means hota hai bacha, almost. Static means rest. That is what? Infinitely slowly, right? Number 1. Very good. Fusible plug. Here I go. Mega best. You are most welcome in the session. Guys, those who have joined the first time, they have to do it, like, share and subscribe the session. A Breton cycle is working between temperature limits 1600 Kelvin and 400 Kelvin. What will be the cycle efficiency for maximum capacity, my dear? For maximum capacity, what it should be? Haji bacha, what it should be? Guys, please tell me what it should be. It should be none other than what? What should be the formula? You can tell me the formula. Haji bacha, what it should be? It should be none other than what, mata? Kya hoga? It should be none other than eta thermal is equal to what? 1 minus under root of 1 T mean upon T max. It is what, my dear? T mean is what? 1 minus 400 divided by 1600. Right? Under root. It should be what, my dear? 4. Yes or no? 1 by 4 means what, my dear? It should be what? 1 minus 1 by 2. That is what, my dear? 0.5. 50%. Very good. Very good morning, Benny. Here I go for next. Ratio of radii of two spheres of metals 1:2. The ratio of amounts of radiation emitted by them at same temperature. You know that it is what, my dear? It is what? E sigma A T raised to power 4. Right? But they said what, my dear? They said that this one is same, temperature is same, right? And they have given the radii right now. Yes or no, bacha? Yes, they have given the radii. Now we have to, okay, now we have to find out what we have to find out, right? So it should be, that means this is directly proportional to what? A. That means what? That means what? I can say E1 by E2 is equal to what? A ke terms mein aayega, it is directly proportional to R square. So it should be what? R1 by R2 square. And my dear, it should be what? It should be what? 1 by 4. Answer will be 1 by 4. Number 1 is correct. Very good. 8:1. No, it should not be 8:1. It is 1:4 aega. Here I go for next. My dear. Flow of carburetor controls what, my dear? Fuel flow rate, fuel and air mixture flow rate, air flow rate. It is level of fuel. Flow will control what, my dear? Level of fuel. Separation of flow occurs when pressure gradient tends to approach 0, becomes negative, changes abruptly, reduces the value. When? It is what, my dear? It is when it changes abruptly. Right? Very good. Here I go for next. My dear. Fourth one. Very good. Beautiful. Here I go. Reduces the changes. Okay. I hope everybody is getting. Yes, my dear. Here I go for next. चले बच्चा आगे. Here I go. What does the term quality indicates? Mass fraction of liquid in a liquid vapor mixture. Mass fraction of vapor in a liquid vapor mixture. What, my dear? Mass fraction of vapor. It is none other than X is equal to mv upon mv plus ml. That is what? Mixture of what, my dear? Liquid and vapor, right? So it should be none other than number 2. Here I go for next. Increasing the compression ratio beyond certain limits result to what, my dear? Delay in fuel burning, engine knocking, excessive heat in engine. That is what? Engine knocking, detonation. Very good. I hope you got it. Here we go. Chitranjan. The maximum net specific work obtainable in ideal Breton cycle is what, my dear? This one and this one. What should be the value? You know that what, my dear? It is none other than Cp under root of what? T3 minus T1. That is what? T3 is nothing but what, my dear? T max. It is what? T mean. Right? Right now? ये क्या है? T1 is nothing but what? Minimum temperature. Right? Square. So it should be what, my dear? T3 is nothing but what, bacha? T3 is what? That is T max. That is what? 900. That is 300. Minus what, my dear? It should be 100. Right? Sorry, T mean is 400. Nah? So T mean is 400. Bahar aayega 200. Sorry, 20 is there. Nah? Sorry. It should be 30 and it should be minus what, my dear? 20 square. That is what, my dear? 100 Cp. Answer will be 100 Cp. Everybody, here we go for next. The thermal efficiency of Carnot engine is 0.5 if the engine is operated at refrigerator. Then COP will be what, my dear? 1 plus COP of refrigerator is equal to COP of heat pump is equal to 1 upon efficiency of heat engine, right? So 1 upon 0.5, that is what, my dear? It is 2. Hi ना बच्चा? अरे हाय ना? 10 by 5 मतलब 2 आ गया. 2 minus 1 मतलब 1. Fourth one. 1. Very good. Here we go for next. The work done in a steady flow process is equal to minus VDP in the Rankine cycle. The turbine work is much greater than pump work because pump में क्या आ रहा होता है? Pump में liquid, that is what VF, and VF is too much smaller than what, my dear? Because the expansion of steam will occur inside the turbine, so definitely the work provided by the turbine will be more, right? Because we have this one, right? So the pressure drop, the specific volume of steam is much higher than that of water. Number 2 is correct. Here we go for next. A gas turbine working a Breton cycle with regeneration, air exists from the compressor at 550 Kelvin. Okay. And gas exits from the turbine at 800 Kelvin. If the effectiveness of the generator is 0.8, then what is the temperature at the combustion chamber inlet? Combustion chamber inlet पे temperature पूछ रहा है बच्चा. They are asking temperature. How we can calculate? Yes, guys, be fast. Guys, be fast. Tell me. हाँ जी बच्चा क्या होगा? Effectiveness. Yes. Effectiveness will be. My dear. Yes. What it should be? क्या हो जाएगी? Effectiveness will be what, my dear? Temperature at inlet of compressor, right? C, combustion chamber, minus what, my dear? It is 550. Right? Divided by what, my dear? It should be 800. Minus 550. You know the effectiveness formula. Calculate TC because it is given. That is what, 0.8. You will get TC. My dear, what is the value of TC? Can you tell me? क्या value आ रही है बच्चा? It should be 750 Kelvin. Very good. 750. 750. Number 4 is correct. Here we go for next. In a spray washing system, if the temperature of the water is higher than the dry bulb temperature of entering air, then the air is, say, you are doing a spray, right? If the temperature of the water is higher than the dry bulb temperature of entering air, so definitely the air will get heated, and in addition to that, it will also get, that is what, addition of moisture will take place, right? That means humidification and heating will take place. That is heated and humidified. Here we go for next. In which type of collector is solar radiation is focused into absorber from the top rather than from bottom? Fresnel lens. What, my dear? Fresnel lens. Yes or no? अरे हाँ या ना बच्चा बोलो. Guys, yes. I think there is a lag. इट इज फ्रेस्नेल लेंस. क्या है बच्चा? वो फ्रेस्नेस लेंस है. ठीक है, चलें आगे. इट इज फ्रेस्नेल लेंस. रिमेंबर. नाउ वी गो फॉर नेक्स्ट. 100% RH, 3 characteristics. At 100% RH means what? Saturated air. It is saturated air. Dry bulb temperature, wet bulb temperature and DVT are what? Equal. क्या होंगे? Equal होंगे. It should be equal. Very good. It should be equal. Here I go for next. A liquid being pumped pressure head, at pump inlet plus velocity head in the suction pipe minus vapor pressure head. That is what, my dear? It is nothing but net possessive suction head. NPSH. What, my dear? It is NPSH. Very good. Here I go for next. Reaction turbine are used for. Reaction turbine are used for what? Low head? No. Reaction turbine means what, my dear? Kaplan propeller and Francis turbine, right? And that are utilized for high discharge and low head. The process of extracting steam at a certain section of turbine and subsequently using the heating feed water supplied to the boiler is called, my dear, क्या बोलते हैं उसको? Reheating or regeneration. That is regeneration. That is regeneration. NPSH. Very good. Everybody is good. Everybody. Correct. Correct. Here I go for next. Which of the following is the desired quality of SI engine fuel to reduce knocking? Higher octane number, lower octane number, higher C10 number, higher NLI number. It is what, my dear? Octane number for SI engine, C10 number for CI engine. That is diesel. Very good. Regeneration. Very good. It's a regeneration. It's a regeneration in steam turbine. It's not a gas turbine. Here we go. A rotameter used to measure. A rotameter used to measure what, my dear? It is measure what, my dear? Flow rate. Aye bacha, be fast. Be fast. It is what? It is what, my dear? It is what? हाँ जी बच्चा, क्या होगा? रोटामीटर किस लिए यूज करते हैं? हम लोग मेजर करते हैं. क्या मेजर करते हैं बच्चा? फ्लो. क्या मेजर करते हैं? फ्लो. वेरी गुड. हियर वी गो फॉर नेक्स्ट. फ्लो रेट. इट इज फ्लो रेट. हियर वी गो फॉर नेक्स्ट. For conduction through a spherical wall with constant thermal conductivity and with inner side temperature greater than outer wall. Temperature. What is the type of temperature distribution? Linear, parabolic, hyperbolic. I repeat. Conduction through a spherical wall with a constant thermal conductivity with an inner side temperature greater than the outer wall. The temperature distribution will be what, my dear? We have seen. It is none other than hyperbolic. क्या होता है बच्चा? हाइपरबोलिक. हियर वी गो. Here we go. Just refer regeneration, you come to know. Chahat. Here we go. Consider the following statement with regards to heat transfer. The temperature variation in lump heat capacity analysis is exponential with time. Yes, we have seen T minus T infinity upon what, my dear? T naught minus T infinity is equal to e raised to power HAT minus upon, rho Cp, right? So that is what exponential. So it's correct. The situation involving simultaneous heat mass transfer, the ratio of convective heat transfer to convective mass transfer varies with Lewis number. No, that is not. Lewis number is nothing but what, my dear? It is a thermal diffusivity of heat to the thermal diffusivity of mass, right? So it's incorrect. So option will be what, my dear? Only one. Only one. Here I go for next. Here I go for next, my dear. Venturi meter works on the basis of what? What is the basis of what principle? You can say Venturi meter. That is none other than, my dear, it's not Newton, it's not Pascal, it's not Archimedes, it's Bernoulli. It's Bernoulli. It's Bernoulli. Okay. Only one. That is option number 3 is correct. Here we go for next. Which one of the following statement does not characterize the fully developed laminar flow in a pipe? Velocity profile does not change in the longitudinal direction. Velocity profile across the pipe section is parabolic and maximum. Velocity gradient in the direction of flow is constant and positive. Velocity gradient, pressure gradient is in direction of flow is constant and negative. Which one is not what, my dear? Characterize. You have to tell me. कौन सा नहीं बताता है? That you have to tell me, guys. Be fast. It's very easy question. We have done this, and you know that. Yes, guys. Please tell me. It is none other than what, my dear? अरे यहाँ जब नेगेटिव बोल रहा है तो डेफिनेटली यहाँ पॉजिटिव आया, सो दिस विल इनकरेक्ट, राइट? हियर वी गो फॉर नेक्स्ट. Bernoulli, here we go for next. The ideal thermodynamic cycle for the development of gas turbine engine is what? Not Otto, not Stirling, not Ericsson, it's Breton. It's Breton. Stirling Ericsson cycle are reversible cycles. For wind turbine, 10 mm, 10 meter long, running at 20 rpm. Okay, 12.9 kilometer per hour. What wind? Okay, wind speed is given. TSR, tip speed ratio. They are asking TSR means what? Tip speed ratio. It is nothing but what, my dear? Velocity at tip to the velocity of wind. Right now, tip velocity at tip. तो टिप पे क्या हो जाएगी बच्चा? टिप पे वेलोसिटी क्या होगी? पाई डी एन बाई 60. टिप पे blade tip velocity, right? It should be what? It should be pi d n by 60. I hope you're getting. I hope you're getting. Here I go. समझ आ रहे हो ना? हाँ जी बच्चा. Here I go. That is TSR. Pi d n by 60. Okay. Here we go. Right. And my dear, here you can see that is 10 meter long. So we want to diameter. So diameter will be what? 2 into L. Right? 2 into L now. So my dear, what we're getting pi, and it should be what? It should be 12.9 and it is in kilometers. So you have to multiply by 5 by 18. Right? So my dear, you are going to get pi. D means what? 2 into L, that is 20. Pi into 20 into N. N is how much? 20. Divided by what, my dear? Multiplied by 18 divided by 60 into 12.9 multiplied by 5. Calculate the answer. And the answer is, my dear, 5.84. 5.84 is a right answer. I hope you got it. 5.84 TSR. Tip speed ratio. Here I go for next. Which of the following devices present in the vapor absorption refrigeration system and upset in VCRS? VCRS में जो absent हो और vapor absorption में जो present हो, evaporator दोनों में present है. Throttling valve VCRS में present है, but absent होना चाहिए. Generator. In order to replace the compound pipe by new pipe will be equivalent when the following are same for both pipes. That is what, my dear, it should be not. Loss of head and flow. Loss of head and flow should be same. Then and only you are able to replace. Very good. Compressor, how it could be compressor, yaar? Compressor, it's generator. They said कि कौन सा present होता है VRS में and absent from VCRS. Okay, here I go for next. A surface having high absorption for short wave radiation. Short wave means what, my dear? Solar radiation. Less than 2.5 micrometer and low emittance of long wave radiation more than 2.5 is called, my dear. You know that. We have used what, my dear? Over absorber plate. If you have seen my lecture, that is renewable energy sources, in that I already explained about the absorber plate. We have what, my dear? Selective coating is there. And this selective coating is what, my dear? Selective coating is what, my dear? It should have what? Haji bacha. It should have high reflectivity. Right? High reflectivity, but its emissivity should be what? 0. That is none other than what, my dear? Selective. Very good. Here we go. Selective. Here we go for next. Angle through which the earth must turn to bring the meridian of point directly in line with sun ray. That is what, my dear? Turn kar diya. That is our angle. What, my dear? Our angle. Very good. Selective coating. Here we go. If you have seen the lectures, okay, a high-speed diesel engine theoretically operates on the today means in modern era, that is in modern days. Nowadays, we are using what, my dear? Dual cycle engine. That is what? Mixed cycle of constant pressure and constant volume. Number 4, dual cycle. I hope you got it, beta. I hope you got it. Here I go for next. If for a fluid flow according to the boundary layer concept, separation occurs when pressure falls to 0, pressure rise in sudden and rapid, different boundary layers comes across sharp turn or bend, boundary layers of the fluid become stationary. Yes, this one is correct. When the boundary layer becomes stationary, at that time there is a chances of what, my dear? Separation of flow, right? And that will cause what, my dear? Separation. Very good. Very good. Here we go. Here we go, my dear. A Breton cycle is working between temperature limits of 1600 Kelvin and 400 Kelvin. Find the value of maximum work. That I already told you. CP is given. That is what, my dear? 1.005 under root of what, my dear? 1600 minus under root of what? 400 square. That is what, my dear? 1.005. It should be what? 1600 means what, my dear? 400. No, it should be 40. 40 minus what? 20. Right now? Am I right? That is what, my dear? Square. That is what? 20 square. 400. 400 something. That is, this one is correct. Third one. 400. 603. 603 कैसे आएगा? 402 is correct option. It's not 6. अखिलेश गुप्ता. 402 आएगा आंसर. यहीं से जब पता चल रहा है 20 आएगा तो definitely it is almost 1. So it should be 0.005 multiply करेंगे, that will get around 2, 1 or 2. Approximately मारा मैंने उसमें. Okay, I have ticked the answer over here. Fourier's law of conduction in a one dimension, which is correct, my dear. That is what? Q is equal to, sorry, capital Q. It's a Q is equal to what? Ka into dt by dx. It's very easy question. Number 1. When Bernoulli equation applicable between any 2 points in flow field, then, my dear, Bernoulli equation is applicable between any 2 points. The flow is steady, incompressible, and rotational. No. Flow should be irrotational. Flow is steady, compressible. No, it should be incompressible. Flow is unsteady. No, it should be steady. The flow is steady, incompressible, irrotational. Number 4 is correct. Very good. Here we go. Here we go, my dear. Here we go. Early mountaineers boiled water to estimate their altitude. The basis of the process is the relation between what, my dear? Partial pressure, right? That is vapor pressure and temperature. Right now, it is number 3. Number 3. Here we go for next. Which of the following statement is incorrect regarding a 4-stroke engine? Which one is incorrect? It requires heavier foundation. Correct. It can be easily started. No, it can be not easily started. So option number 2 is correct. And it required more cooling time. Yes. It occupies greater space. It's also correct. But number 2 is not correct. 2-stroke engine is easily started. Okay. Here I go for next. Here I go for next. If the temperature of the hot reservoir is increased, the efficiency of the Carnot engine. Efficiency of the Carnot engine, you know that, my dear. What? It is none other than 1 minus TL upon TH. If you increase this, this will get small. If you get small, efficiency will rise. Alright? So temperature of the hot reservoir is increased. Efficiency will what, my dear? Increase. Increase. Okay. Here we go for next. Guys, do it, like, share and subscribe. इसमें कमी मत करना. A freon tell. Okay, operates a temperature limit 35 degrees centigrade and minus 15 degrees centigrade. Okay, the condenser and evaporator, if the refrigeration effect produced is 1.5 and work required to compressor is this much. Okay, the value of COP will be what, my dear? The 111.5 divided by 27.2, and it should be 27 to the 54. 27 to the 54 and 54 multiplied by 2 again, that is 108. I mean, it should be around 4 point something. It should be none other than, my dear, this one. Approximately, I have done the calculation. Remember. Okay. I hope you got it. Very good. Here we go. Which of the following is not true for heat pump? Heat pump, low temperature reservoir is conditioned space. No. Here in heat pump, our high temperature space is what, my dear? Or reservoir is our conditioned space. So which one is incorrect? Because they have to which not true. Number 1. I will not check other options. Okay. Which of the following are applied or use ways of compounding steam turbines? Haji bacha, pressure compounding and velocity compounding. So which should be? Pressure compounding is what, my dear? Delaval turbine. It is what, my dear? Curtis turbine. Right? Sorry, it's a Rative turbine. Rative. Delaval normal impulse turbine. Okay. Curtis, 1 and 3 is correct. Number 4. Very good. 1 and 3. 1 and 3. Very good. Here I go. Here I go. 1 and 2. 4 1 will be correct. Here I go. Correct statement for first law of thermodynamics. Total energy of system and surrounding remain constant. Work done by system equal to the heat transfer by the system. No. And they said what? Correct statement. Okay. Internal energy of system remain constant during a process. No. Entropy of, that means what? This one. Number 1 is correct. I hope you got it, beta. Yes. I hope you got it. Okay. चलें हाजी बच्चा चलें आगे. Can we go ahead? Yes. My dear, can we go ahead? Here we go. Here we go. The law that forms basis of measurement of temperature. 0th law. Which, my dear? 0th law. Number 1. Fully developed laminar flow through a circular pipe with Reynolds number RE, the friction factor. Friction factor, what, my dear? It is nothing but what? 64 by RE. That is what? F is inversely proportional to what? RE. So it is what? This one. Which one of the following statement is correct for the velocity potential? Velocity potential. Existence of velocity potential is an indicator of irrotational nature of flow. Velocity automatically satisfies contained equation. Velocity potential can be defined only for two-dimensional flow. Guys, please tell me which one is correct. Which one is correct? Hari bacha, which one is correct? Please tell me. Guys, be fast. Be fast. Haji, guys, be fast. Please tell me. So here the option will be what? Existence of it. What, my dear? Velocity is indication of irrotational nature of flow. Here I go for next. Only one. Not all. Not all. Velocity potential. The two-dimensional के लिए भी three-dimensional के लिए भी define करते हैं. It is not stream. It is velocity potential function. Here I go for next. Number 1 is correct. Here I go. A two-dimensional flow. Okay, it is given. The equation of streamline. Equation of streamline is what, my dear? Dx by u is equal to what? Dy by v. Right? Put the value, get the answer. Dx. What is u? That is x. And dy, that is minus y. So it should be what? It is ln of x is equal to what, my dear? Minus ln of y plus ln of c. Right? Yes or no? Guys, yes or no? Please tell me. Yes or no? Guys, yes or no? Here we go. Okay. So that means I'm going to get what, my dear? Ln of xy is equal to ln of c. That means xy is equal to c, right? And at 0.11, that means c is equal to 1. Right? C is equal to what, my dear? C is equal to क्या आ गया हमारे पास? 1 आ गया ना? So what we are getting? What we are getting? That we are getting sy is equal to 1. That is what, my dear? Xy minus 1 is equal to 0. So option number this one is correct. Here I go for next. Here I go for next. Pre-ignition is caused by spontaneous combustion of the mixture before the end of compression stroke and is due to. Pre-ignition is caused by the spontaneous combustion of the mixture before end of compression stroke and it is due to what, my dear? Cylinder was being too hot. Correct. Overhead spark plug points. Right. Overheated spark plug. Red hot carbon deposit on the cylinder. It's also correct. That means all are correct, my dear. All are correct. Okay. Nusselt number is what? 390. Reynolds number is 39. Prandtl number is what, my dear? 20. Stanton number. Stanton number. Guys, can you tell me what should be the Stanton number? Haji bachcha, Stanton number. क्या होगा Stanton number? Guys, can you tell me? Haji bachcha. It is what? Stanton number is nothing but Nu upon Re into PR. Nusselt number divided by Re into PR. Guys, what should be the answer? Please tell me. कितना आ रहा है answer? Yes, tell me the answer for it. It is 0.5. It is what? 0.5. 0.5 is correct. Real gases behave as ideal gas on high temperature, low pressure, high temperature, low pressure, low temperature, high pressure. My dear, be fast. It's a very easy question. Which one is correct over here? It is what? Low pressure and high temperature. Okay. So which option is correct? Okay, there is a lag, I think. There is a lag. We'll wait. Don't worry. Now tell me the answer for it. It should be what? It should be low pressure and high temperature, right? Number 3 is correct. Here I go for next. Refrigeration cycle. If vapor is not superheated after compression, then it is called. See, if the vapor is not superheated after compression, then it is called what, my dear? It is vapor compression, dry compression, wet compression, subcooling. What I see, if the vapor is not superheated after compression, that will be what, my dear? Wet compression. Okay, number 4 is correct. Number 4 is correct. Here I go for next. Plastic sleeves of radius outer, that is what? RO 1 mm. Cover a wire of radius 0.5. Okay. Carrying electric current, thermal conductivity, that is 0.15, and heat transfer coefficient exposed to air is what? 25 meter. Due to the addition of plastic cover, what? The heat transfer from, you have to identify what? RC, and that will be what, my dear? K by H. So K is what? 0.15 divided by what, my dear? 25. Right. Now tell me the answer for it. Tell me the answer for it, guys. Be fast. हाँ जी बच्चा, क्या होगा? आंसर क्या आ रहा है इसका? Yes. It should be what? So इसको एक काम करो, मल्टीप्लाई कर देना 1000 से. So you are going to get what, my dear? RC आ जाएगा आपका 6 mm. Right? RC is what? 6 mm. So here, you know, RO is what? 1 mm. So इसके ऊपर इंसुलेशन लगाओगे. कब तक लगाओगे? जब when you are getting the insulation up to 6, that you are going to get what, my dear? Heat transfer, increase in heat transfer, right? But when you cross this 6, you are going to get what, my dear? Heat transfer will drop, right? So it is what? Initially it will increase. क्या होगा? Increase होगा, right? Increase होगा. Here I go for next. Identify the incorrect option from below with regards to the first law of thermodynamics for a cyclic process where W net is this and that. Okay, which one is incorrect? Which one is incorrect? You have to identify, my dear. W net is equal to QH minus Q1, heat rejected of the cycle, and Q1 is what, my dear? Heat supplied. It's correct. Heat of cycle will be what, my dear? Q1 upon QH. No, it's wrong. It's wrong. यही गलत है. Number 2. Number 2 is wrong. Here we go for next, my dear. Here I go for next. A solar tower power system, each mirror is mounted on system called what, my dear? Regenerator, linear Fresnel dish, heliostat. It's what, my dear? Heliostat. हाँ जी बच्चा, heliostat होगा. Guys, be fast. Be fast. Please tell me which one. Which one correct? Which one कौन सा correct है? हाँ जी बच्चा. Which one? Very good. 4th one, heliostat. Here we go for next. Reynolds analogy where Prandtl number is equal to unity. Okay, Prandtl number is equal to unity. Standard number will be equal to, you know that what, my dear? Kanban analogy. क्या थी बच्चा वो? क्या थी? That analogy is what, my dear? Can you tell me? हाँ जी बच्चा, it is what? क्या था वो? Standard number multiplied by PR raised to power 2 by 3 is equal to what? Friction factor divided by what, my dear? 2 ना. So they said अगर ये 1 हो जाए 1, okay, the standard number will be equal to what? CFX by 2, that is friction factor divided by 2, half of the friction coefficient. Correct. Here I go for next. Nusselt number divided by Reynolds number, Prandtl number. It is none other than what, my dear? Stanton number we have already calculated. Okay. Power required to drive centrifugal compressor is proportional to, that you have to tell me. हाँ जी बच्चा, be fast. थोड़ा जल्दी कीजिएगा. Guys, be fast. Which one is correct, my dear? Which one is correct? Which one is correct? Yes. हाँ जी बच्चा, which one is correct? You know that power is equal to what, my dear? It is what? Rho G Q H. And you know that Q is equal to what, my dear? D cube into N. That means I can say is equal to constant होता है ना. So Q is directly proportional to N हो गया. And you know that what, my dear? H model type के लिए हमने देखा था D square upon N square. So H is directly proportional to what? N D square and N square. That is what? N square. यहाँ पे N पूछा है ना. So it is what? N and N square. That is what? Cube. Number 3. Number 3 is correct. Here we go for next. Minor losses in a piping system are what, my dear? Less than the friction losses. Less than the friction losses due to viscous stress. Due to the viscous stresses, okay, assumed to vary linearly with velocity or found by using loss coefficients. My dear, it are nothing but they are found by loss coefficients. We have different coefficients, right? Yes or no, bacha? I hope you got it. I hope you got it. This fourth one. Here I go for next. Here I go for next. Guys, do it, like, share, and subscribe. Do it, like, share, and subscribe. The most correct. Fourth one is correct. Fourth one is correct. Here we go for next. And the assumption in lump heat parameter analysis. In assumption, what we assume? The temperature should be remain same at different instant at a particular time, but it should be changed with respect to time only. That means time के साथ एक particular time पे it will not be a function of spaces, right? मतलब वहाँ same होगा, but it can change with respect to time. That is what? Temperature is not function of this x, y, z, but it is a function of time. Okay, that is number 4. A body one in the form of sphere, 2 centimeter radius, and temperature T1 is located in the body 2, which hollow cube 5 centimeter side and is at temperature T2. T2 is greater than from T1. The shape factor F21. You know that there is a cube. I'll draw the cube 2D in 2D only. Okay. And it is what, my dear? It is what? It is your 1. It is your 2. So, my dear, you know that A1 F12 is equal to what? A2 F21. F11 will be 0. Right? F12 will be what, my dear? 1. So A1 is equal to what? A2 into F21. You have to find out F21 now. So F21 will be what, my dear? It is A1 by A2, and A1 is nothing but sphere. That will be what, my dear? 4 pi square divided by A2. A2 will be what, my dear? 6A square. Calculate. Guys, calculate. Be fast. कितना आ रहा है आंसर? Guys, be fast. Please tell me. हाँ जी बच्चा. What it should be? 4 pi square divided by 6A square कर दो. कितना आ रहा है? 0.335. अरे भैया ये आ जाएगा 4 pi square divided by what? 6A square. ये आ रहा है आंसर 0.335. That is 0.34. Okay. I hope you got it. Here we go for next. वहां less than बोला है. Less than से नहीं होगा. That you have to calculate by the loss coefficient. जो value loss coefficient आएगी, दोनों चीजें होंगी. क्यों नहीं होगा? See, the thing is कि loss coefficient से value accurate आएगी. You get it? वो उस पर क्या डायमेंशन दिया, क्या पैरामीटर्स दिया, उस पर भी डिपेंड करेगा कि कितना दिया हुआ है. आप पाइप लॉस स्ट्रेस थ्रू द पाइप, जो फ्लो थ्रू पाइप पढ़ते हैं उसको पढ़िए, आपको ध्यान में आ जाएगा. ओके, हियर आई गो. Convection heat transfer from hot flue gases. Convection heat transfer from a hot flue gases to a water tube. Even though flow may be turbulent, the laminar flow region. क्या पूछ रहा है? Laminar flow region, boundary layer of the film exist close to the tube. The heat transfer through this thin film takes place by, my dear, क्या होगा? क्या होगा? हाजी बच्चा, it should be conduction. It should be what, my dear? Conduction. Okay, here I go. Here I go. It should be conduction. Here I go for next. An open system is what? It's specified region where the transfer of power. No. Region constant mass. Only energy is allowed. No. Cannot transfer either in isolated area. Has a mass transfer across its boundary, and mass within the system is not necessarily constant. Of course, that means what? Transfer of energy and mass is allowed. That is number 4. The efficiency of Carnot engine, what, my dear? In that is what it is. You know that TH minus TL upon TH. Number 1, compression process is carried out in a cylinder containing nitrogen of mass 0.3 kg, 100 kilopascal, 40 degrees centigrade to 1 megapascal, 140 degrees centigrade. Work done in the system is 30 kilojoule. Take CV is equal to this much. What is the amount of heat released during the process? Guys, please tell me. हाँ जी बच्चा, which one is correct? कौन सा होगा, कैसे निकालेंगे? हाँ जी बच्चा, it should be none other than what, my dear? Just apply the first law of thermodynamics. क्या करेंगे? First law of thermodynamics लगा दो, that is dq is equal to what? du plus dw, right? And you know that dq you have to calculate. Du will be none other than, du will be what, my dear? mcv dt. M is given, that is what? 0.3. CV is also given 0.7. dt is given what, my dear? 40, that is 100. Right? Calculate it. That is what? 21, I think this one. This is 21. Right? It's 21. Right? So it should be 21. And what, my dear? Work done on it. So it should be what, my dear? Minus 30. Right? So dq will be what, my dear? 9 kilojoule. It should be not 9 kilojoule. Right? Of course, it should be 9 kilojoule. Okay? That is minus 9 kilojoule. That is what they have already mentioned. Now, what is the amount of heat released during the process? Release means what? Rejection. Rejection is always negative. Rejection is always negative. So it should be 9 only. Okay. Here we go for next. For a laminar flow occurs in a zigzag way. Reynolds number lies between 2000 3000. No, it should be less than from 2000. Newton's law of viscosity is importance. None of these. This one. Because Newton's law of viscosity, why it is important? Because Newton's law of viscosity focus on what, my dear? Focus on what? Viscosity, right? And you know that RE is going to be defined by, RE define the laminar flow. So RE, you know that what, my dear? Rho Vd by mu, right? So that's why Newton's law of viscosity will play an important role. In a centrifugal pump, discharge is proportional to, my dear. Can you tell me? We have already seen this. So yes, can you tell me whether it should be N only or anything else? Guys, be fast. बच्चा क्या होगा? हाँ जी, be fast, my dear. It should be what? It should be, we have already learned Q is equal to dQ by N is equal to constant. So definitely it is this one. That is N only. Very good. Here we go. Guys, all of you are most welcome. Please do it, like, share, subscribe the session. In an impulse turbine, if the angle of blade tip at the outlet is 60 degree, the maximum hydraulic efficiency, you know that it is what, my dear? 1 plus cos of alpha by 2, eta max. And here alpha is what? 60 that you'll get what, my dear? You'll get around 1.5, that is 1.5, that is 0.75, that is 75%. Right? Maximum dimension of the edge of the solid aluminum cube, okay, which is subjected to convective heat transfer with H equal to 30. The lump parameter analysis to be fairly accurate is, my dear, can you tell me? Maximum dimension, we have to calculate LC. Yes, bacha. Be fast. Jaldi karo thoda. Guys, tell me what should be the answer for it. हाँ जी बच्चा. We have to calculate A. We have to calculate A, my dear. So you know that what, my dear? Biot number is what? Less than should be 0.1, and Biot number is what, my dear? HLC by K. So H is LC by K, and LC is nothing but what, my dear? LC is V by A. So यहाँ पे आप करोगे, so क्या maximum dimension of a solid aluminum cube which is subject to यहाँ पे अगर V by A निकालोगे cube का, तो it should be A by 6 आएगा. Okay, so my dear, what you'll get H LC is what? A, that is side of cube, and my dear 6K, and that should be less than from what, my dear? That should be less than from 0.1. Right now, hi na bacha. Guys, yes or no? So H is given. H is how much? H is 30 divided by 6K. That is what? It should be less than from 0.6K. Am I right? Yes or no, बच्चा? आ रहा है कि नहीं आ रहा है आंसर यार? आ रहा है. Okay. Right now. Right? Yes or no? and that it should be less than equal to, right, it should be what 6, right? K we have, that is what my dear, K कितना है हमारे पास, K is given 250, right? So I'll get A is equal to 0.6 into 250 divided by, it should be less than or equal to what my dear, divided by what, how much, 30. Now my dear calculate, so A should be less than or equal to कितना आ रहा है बच्चा, it should be how much, it should be 5 meter, it should be 5 meter, कितना आ रहा है 5 meter, right? So my dear what should be the answer will be what, 5 meter से कम होना चाहिए, so एक ही पैरामीटर है, that is what, it should be either equal to 5 meter or 2.5 meter. So which option will going to be correct? हाँ जी बच्चा, which option is going to be correct? Guys be fast, tell me, जल्दी बताओ थोड़ा सा. It should be 5, it should be 5, एक तो 5 के बराबर हो या 5 से कम हो, okay? It should be 5, हम बड़ा वाला लेंगे, okay? Here we go, 5, here we go. For calculation of heat transfer by natural convection from a horizontal cylinder, what is the characteristic length of Grashof number? Grashof number जब हम लेते हैं और किसकी बोल रहा है वो, horizontal cylinder की. My dear we consider what, diameter. क्या होता है diameter of the cylinder. But this cylinder when supposed to be it is vertical, then we have to take what my dear, अगर ये vertical हो जाए then we have to take length, okay? Identify the incorrect statement from the following options. Conventionally, a domestic refrigerator, the coil tubes at its back, that is black color coil, it is somewhat like this. If you have seen your backside of your refrigerator, carry refrigerant fluid, right? Carry chilled water, no. So what did they say? Which its back, identify incorrect, it does not carry water, right? Number 2, it rejects heat atmosphere, serves as condenser, yes, it's correct. Which one of the following is a dimensionless number? Identifies the compressibility effect of the fluid, and that is none other than what my dear, that is none other than what, it is the inertia forces to the elastic force, that is Mach number. कौन बताएगा, अरे under root of what my dear, inertia forces to viscous force, that is Mach number will identify the effect of what my dear, identify the compressibility effect. Here I go for next. Which of the following is a non-positive displacement type compressor? Which of the following is the non-positive type displacement condenser? Guys be fast, थोड़ा सा जल्दी बताएं, it's very easy question, guys be fast. And the answer is axial flow compressor. Very good. क्या होगा बच्चा? Guys please tell me the answer for it. Mach number. What about next question? Yes, it should be what? Very good. Axial flow compressor is there. Okay, axial flow compressor. Here we go for next. When an orifice for flow measurement in a pipe is replaced by a venturimeter, orifice has been replaced by a venturimeter, the pressure drop for the same flow is expected. My dear, you know that pressure drop, that is the change in delta P is inversely proportional to what? CD, right now. And you know that CD of venturimeter is quite higher than discharge coefficient of what? Orifice, right now. So definitely it will be higher, then my dear it should be what? Drop, that is what? Decrease. Okay, very good. Here I go for next. In the Rankine cycle, expansion of steam assumed to be, Rankine cycle में क्या assume करते हैं? Isentropic. In which of the following aircraft refrigeration system use two turbines? That is what my dear? Reduced ambient system में, because at that time what my dear, जो force air होती है, that is ram air is quite have a high temperature, so एक circuit को जो cool कर रही होती है वो इसको भी cool करती है, so that's why we are using two turbines over there. Okay, I hope you got it. Here we go for next. A pipe carrying steam, enthalpy this one at flow rate 1 kg per second. Another pipe carrying, okay, this one, they mixes adiabatically. Flow in the single pipe. Okay, find enthalpy of resulting pipe. Okay, so एक pipe यहाँ से आया, एक pipe यहाँ से आया, दूसरा यहाँ से चला गया, right? So यहाँ पे कितना है? 3 specific 3000. Mass is 1, that is what? ये 3000 ही हो जाएगी. It is 25. क्यों है? Per kg ना? We have mass is what? 2 kg. So definitely ये क्या हो जाएगा? 25 into 2, that is what? 5000. और यहाँ पे क्या होगा? That is mass will get combined. That is what? 2 plus 1 is equal to 3 into h. And we have to identify. So my dear, 3h will be what? is equal to 3000 plus what, my dear? 5000. Right? So it should be what, my dear? 8000. Higher na bacha? It should be what? 8000 divided by 3. Tell me the answer. H is equal to, my dear. What is the answer of this one? Guys, be fast. Answer kya hai? The answer is 2667. कितना बच्चा? 2667. 2667. Number 2 is correct. Very good. Here I go for next. 2. In new scale and of temperature is divided in such a way that the freezing point is 100, okay, and the boiling point is 400 Newton. You know that what is the temperature? Both the Celsius and this new temperature scale reading will be same. My dear, what is the formula? You know that. You should remember this. What boiling point? Boiling point is what of new scale? What this one supposed to be? It is the actual temperature supposed to be. I take it is what Tn. All I say that they will equal at temperature T. Okay, and it is what difference between BP and ice point. That is what 400 minus 100. That should be what, my dear? 300. 400 minus 300. It is 400 scale, and it should be what, my dear? Boiling point is what? 100 minus T divided by what? 100 minus 0. That is what? 100 only. My dear, from here you will get T, and T will become, my dear, minus 50, I think. Minus 50 aega answer. Guys, yes or no? Please tell me. Answer is what? Answer is minus 50 now? Okay, that's good. Okay, here I go. Here I go. For a same compression ratio, the Brayton cycle efficiency equals to what, my dear? Equals to Otto cycle. Otto cycle के बराबर हो जाती है 1 minus 1 upon RP raised to power gamma minus 1 upon gamma is Brayton, right? And what is Otto? 1 minus 1 upon RC raised to power gamma minus 1, that is gamma. Okay, वो दोनों इक्वल हो जाएंगी. रिलेशन निकालना पड़ेगा P2 by P1 and T2 by T1 and V1 by V2 का. Okay, here I go. Very good. Detonation in SI engine becomes severe during what? It should become severe when there is a high load and speed is low. When there is a load, it should be high and speed should be low. That is number 4. Right? Very good. Here I go for next. Here I go for next, my dear. Here I go for next. Is defined as the amount of dry saturated steam generated from feed water at 100 degrees centigrade at normal atmospheric pressure. That is what, my dear? Equivalent evaporation. It's not degree of superheat. It's not boiler thermal efficiency. It's dryness fraction. अगर supposed to be इस question का आंसर मुझे पता भी नहीं होता, I can eliminate कि ये मेरे को पता है, and I know that this 2, 3, 4 will not be option. So the only option remains, that is what, this one. So this will be the correct option. Right? Elimination technique is very useful. I repeat, the elimination technique, my dear, it's very useful. Okay. Here I go for next, my dear. The working cycle in case of 4-stroke engine is completed in number of revolution. किसमें बच्चा? 2 में. Right now, 4-stroke engine 2 revolution में 1 power stroke. Work done in a compression 1 kg of air in compression will be list when the value of index, you know that it is what, my dear? It is what? It is minimum in isothermal process, right? Isothermal process may we have a way, what, my dear? List work input for compression, right? So, my dear, that equation is what? PV is equal to C. So, that is PV raised to power V is equal to C, and we have general equation PV raised to power K equal to C. So, my dear, here what should be the value of this K? K should be what? 1. Very good. Number 1 is correct. Here I go for next. Isothermal. Very good. Which of the following is not a dimensionless parameter? Dimensionless कौन सा नहीं है? I know that. मेरे को यही दिख गया. Kinematic viscosity. Don't check about this one. ये है नहीं है. Reynolds number नहीं है. You know that. Friction factor भी नहीं है. Pressure coefficient का भी unit नहीं होता. Right? Kinematic viscosity is what, my dear? Meter square per second. So it have dimension. यहाँ पूछा है which one is not dimensionless. So it have dimension. So number 4 is correct. Good refrigerant should have what, my dear? High latent heat of vaporization and low freezing point. Number 1. Area of actual indicator diagram is 20 centimeter square and base width indicator diagram is 10 centimeter and spring constant is this one. The mean effective pressure will be My dear, what it should be? Guys, please tell me. It should be none other than what, my dear? Main effective pressure क्या होता है बच्चा? It is A by L into K. A by means what? Area is what? 20. Sorry, A by L, huh? A by L, not K. A by L into K, right? Right? And it should be what? A is what, my dear? 20. L is what, my dear? 10. Okay. Multiply by K. That is what, my dear? 5. So that is what? 40. 40 nahi hai. We have done mistake somewhere. Where we have done mistake, my dear? What we have done mistake? A by L into K, right now? It's correct, right? Yes, guys, please tell me. Correct hai na? So where we have done mistake? 88, sorry. Guys, tell me the answer for it. It is what? A by L into K, na? Right? So I have taken A by L. A means what? 20. L means what? 10. K is what? 5. I have taken 5, right? Oh, written ulta opposite लिख दिया था मैंने, right? It should be what? 10. Sorry for that. On a pressure volume diagram, the process line PV raised to power n is equal to C. As the value of n increases, will, my dear, will. See. ये डायग्राम हमने देखा था कंप्रेशन के लिए, राइट? Right now, and as you increase n, this diagram moving towards what, my dear? Towards what? ऐसे हो जाएगा, वर्टिकल हो जाएगा कि नहीं हो जाएगा? जैसे जब आप इंक्रीज करोगे फिर आपको ये वर्टिकल लाइन मिल जाएगी, and that will be nearby to what, my dear? That will be nearby to y axis only. Yes or no? Guys, yes or no? And somebody like, नहीं सर मैं एक्सपेंशन केस लूंगा. एक्सपेंशन केस में भी like this one. So पहले ऐसे होगा, फिर ऐसे होगा, फिर जितना इंक्रीज करोगे you will get this line, and that will be again closer to what? This one. Okay? I hope you got it. Close to y axis. Very good. Here I go for next. In a pipe laminar flow in a fully developed region, the constant heat flux from the pipe wall bulk mean temperature of the fluid. किसके लिए बोला है? For constant heat flux. For constant heat flux, that is what? Pipe wall temperature increases in flow direction. Pipe wall temperature decreases, remains constant, increases. What? The bulk mean temperature increases, but pipe wall temperature remain constant. Pipe wall temperature increases in the flow direction. My dear, please. It is when there is a heat flux, my dear. For constant heat flux, both are increasing. Both are increasing. But my dear, when it's all about what? When it's all about the constant temperature, बोल देता है यहाँ पे, supposed to be in place of heat flux. If they replace temperature, then my dear, I want to tell you, at that time only the bulk mean temperature is going to increase. Okay? Wall temperature will not going to increase. Please remember. Very good. Here I go. Consider the following statement regarding ramjet. Engine has neither compressor nor turbine. Right. It operates at higher temperature than a gas turbine. It is also right. And cannot operate statistically. It need to be put in a flight by some means at sufficiently high speed before producing any thrust and propels itself. My dear, 1, 2, 3 are correct. Yes, 1, 2, 3 are correct, my dear. Yes, na? Aji bachcho, 1, 2, 3 are correct. 1, 2, 3 are correct. Okay, here I go for next. All are correct. Here I go for next. Carnot cycle efficiency depends on temperature range. Number 4. It's very basic question. कोई भी निकाल देगा उसको. 1 ton of refrigeration machine means what, my dear? 1 ton of refrigeration means mass of the machine. No, it is 1 ton of ice melts from 0 degree centigrade in 24 hours. Either you can extract the heat from a water at 0 degree centigrade within 24 hours, or the cooling effect produced by melting, uniform melting of what? 1 ton of ice or from 0 degree centigrade in 24 hours. That is what, my dear? That is what? It is most correct, actually. It is most correct. Number 1. Okay, temperature only. Very good. 1 is correct. Here I go. Very, very good. Here I go for next. A spherical distribution of radiation from black body T1 is given. T1. It is T1. It is T1. T1 is what, my dear? 300 Kelvin. Has maximum at wavelength L lambda max. The body cools down to temperature T2. It is T2, my dear. Okay. Wavelength corresponding to the maximum or spectral distribution at T2 is 1.2 times that of original wavelength. Then the temperature T2, you know that, my dear, lambda m into T is what, my dear? Constant. That is 2898. You know that, right? My dear, what you can do, that is lambda 1 T1 is equal to lambda 2 T2. So lambda 1 T1 is given. T1 is how much, bacha? 3000. Lambda 2, that is what? 1.2 lambda 1 into T2. This will get cancelled out, my dear, right? It is 3000 now. So you have to divide it, what, my dear? 3000 divided by 1.2, and that will come around what? T2. And my dear, T2 is how much? देखो, अब देखो, इसको कैलकुलेशन करने की जरूरत नहीं है. देखो, it is divided, so definitely ये तो हो नहीं सकता, ये भी नहीं हो सकता, ये भी नहीं हो सकता. So definitely ये आंसर होगा. Number 1. Very good. Here we go for next. Undesirable property of refrigerant. It's what, my dear? Is its low viscosity, high miscibility with the lubricating oil, low latent heat of evaporation. Because we need high latent heat of evaporation. Okay. A hot body follows Newton's law of cooling. Typically, temperature time graph of body. I hope it's visible. Yes, it's visible. No issue on that. Okay. So, my dear, ऐसे होगा with respect to time. जैसे जैसे time जाता है, the temperature difference कम होता है and the heat transfer get what, my dear? Reduce. धीरे धीरे कम होने लगता है and temperatures क्या हो जाता है? Steady हो जाता है, right? At equilibrium state. So definitely ये तो नहीं हो सकता. अब ये देखो दिखा रहा है, but ये भी नहीं है because इसकी जगह पे कौन सा है? ये वाला. ये ऐसा नहीं होगा, ऐसा होगा. I hope you got it. Positive. And ये linear है, ये तो हो ही नहीं सकता. Okay? Because ये स्टेडी हो रहा है, देख रहे हो आप, पहले ड्रॉप हुआ, रैपिडली काफी ज्यादा डिक्रीज हो रहा है एंड एट दैट टाइम जैसे जैसे नीचे आ रहा है तो थोड़ा सा स्टेडी हो जाएगा, ऐसे चला जाएगा. ओके, सो नंबर 4 इज करेक्ट. सो नंबर 4 इज करेक्ट, माय डियर. ओके, हियर आई गो फॉर नेक्स्ट. If a waste steam has 2 kg of water and 60 kg of steam, then dryness fraction. Dryness fraction is what? MV upon MV plus ML. MV is what? Vapor. Steam has 2 kg of water and 60 kg of steam. So 60 divided by what? 60 plus 2. Right now, answer will be what, my dear? कितना आ रहा है आंसर? 60 divided by 62. Guys, please tell me. It should be nearby. हाँ जी बच्चा. What it should be? Guys, please tell me. Be fast. Be fast. Yes. It should be none other than what, my dear? It should be none other than. कितना आ रहा है? Guys, tell me. Very good. 0.96. 0.96 आ रहा है यहाँ पे. Okay. Here we go for next. Condition of refrigerant after leaving compressor and before entering condenser is ideally. That is what? At the entry of condenser, what is the condition of vapor refrigerant? That is what? Superheated. We know that ऐसा diagram है ना? Right? Yes or no बच्चा? ऐसा कुछ diagram बनता है. Remember? Right now, it is what? Superheated. So it is what? Superheated vapor. Here I go for next. The rate of heat addition and rejection in industrial heat pump is 750 kilowatt and 1000 kilowatt respectively. If the heat pump operates between this and this, the COP will be what, my dear? Higher heat, that is what? 1000 divided by what, my dear? 1000 minus what? 750. That is what, my dear? It should be 4. It will be what? 250 divided by the 1000 divided by 250. We're getting 4. Next question. Thermal conductivity of solid metals with rise in temperature normally क्या होती है बच्चा? Increase or decrease? हाँ जी बच्चा, it should be क्या होती है? Decrease. Very good. That means here we have finished the 100 question, my dear. Here we have finished the 100 question. Here we have finished the 100 question. Okay. So guys, we have another session at 3 p.m. and one more thing that I want to tell. We are going to UPPSC. Those who have new, my dear, you can do it, like, share, subscribe this channel. And UPPSC is going on at what, my dear? Daily 11 a.m. Okay, daily सुबह 11 बजे. And my dear Vizag, we have Vizag timing is what, my dear? 3 p.m. daily. 3 p.m. daily. And now we are dealing with what, my dear? Only mock. And my dear, we are going to continue up to 11 only. That's it. 11 code, that will be the last session based on UPPSC and Vizag. Okay, I hope you got it, beta. 11 तक कर पाएंगे आप. देख लेना चाहत. लेट मी टेल यू, आपने क्वेश्चन ढंग से पढ़ा नहीं, दैट मींस यू आर व्हाट यू आर डूइंग. रीजनरेशन में आप क्या करते हैं? व्हेन यू डू द रीजनरेशन, व्हेन यू डू द रीजनरेशन इज अ स्टीम टरबाइन इन रैंकाइन साइकिल, व्हाट यू डू, एक ओपन फीड वाटर हीटर सिस्टम होता है, उसमें एक होता है क्लोज फीड वाटर हीटर सिस्टम, राइट? उस चीज को देख लीजिएगा. यस, एज फॉर सुपरटेक इट्स डेली होता है. यू आर मोस्ट वेलकम. बट वो उसने किसके रिगार्डिंग में पूछा था? रैंकाइन साइकिल में. एंड दैट ईयर व्हाट माय डियर, वहां प्रोसेस नहीं पूछा था, वो किस में होता है ये पूछा था. वो किस में होता है ये पूछा था. प्लीज ट्राई टू फील दैट क्वेश्चन. आई विल प्रोवाइड द पीडीएफ ऑफ द क्वेश्चन, आप उसको देखो एंड देन प्लीज लेट मी नो. क्वेश्चन कौन सा क्वेश्चन है? क्वेश्चन नंबर कहां पे? Where is the question number? You can see the PDF. I will not switch. You see the PDF and then let me know. Okay. In a Rankine cycle, okay, regeneration is also a process, my dear. Remember, reheating is also a process. Intercooling is also a process. Okay, so guys, this is from my side, and I want to tell you that we are also doing and you are also doing what, my dear? That is, we are also providing, that is session on Vizag at 3 p.m. Okay, 3 बजे शाम को होगा Vizag का, and in Vizag also we are planning mock. Let's see that what we'll do. Okay. So guys, we'll see you in the next session. Yes, anybody have any queries? No queries now. And remember, at 11 we are going to wind up. Okay. And I have covered the renewable energy. Solar part is sufficient. Solar part मैंने पूरा cover कर दिया. अभी तो उसमें those who are interested for what solar, that is renewable energy sources, in that I have covered only a solar part, including geometry of the earth. And one more thing that I want to tell you. कि if you have to learn biomass, and my dear wind भी देख लेना है आपको. Wind and biomass, and biomass 10 minutes 15 minutes का टॉपिक है, and wind energy hardly 30 minutes. Okay, so guys, you can explore that content also. Definitely I'll try कि मैं उस पे सेशन कर पाऊँ biomass पे and wind energy पे. And remember one thing, just अगर आपके पास में समय नहीं, right now we have very less time. So what you can do, you can just see and just turn the pages and see the different terms like TSR, right? We have wind speed ratio, each and everything. Blades कैसे होते हैं, what is their angle, like key points you have to see. Don't read. Okay, I hope you got it. And guys, the admit card is out, right? Admit card of UPPSC is out. I hope. नहीं नोट्स नहीं दे सकते. आई एम सो सॉरी फॉर दैट. नोट्स नहीं दे सकते, बिकॉज नोट्स देने में मैं डीटीपी टीम के पास भेजूंगा, वो डीटी टीम फिर काम करेगी, फिर वो नोट्स अपलोड होंगे, पता तब तक पेपर हो जाएगा. सो इट्स बेटर मैं कोई सेशन कर दूंगा. एंड वन मोर थिंग दैट आई वांट टू डू सेशन ऑन व्हाट, माय डियर? I will do the session on, I will try, not sure, okay, on what, my dear? Biomass energy as well as in wind. उस पे देख लेंगे. सपोज टू बी हार्डली विल गेट 1 घंटे में दोनों फिनिश कर देंगे. ओके गाइस. ओके, सी आई टेल यू वन मोर थिंग. मैं आपको बता दूं कि व्हेन यू सी द ऑप्शंस ना इन द एग्जामिनेशन, सो माइट बी समटाइम्स यू सी ईएस में क्वेश्चन ऐसे ही होते हैं. एंड जो क्वेश्चन मैंने बताया था वो दैट इज फ्रॉम ईएस, आई थिंक. So ES में क्वेश्चन ऐसे होते हैं कि that multiple options are correct, but the thing is that you have to choose the most correct. Okay, most correct option. Okay, you have to choose the most correct option. So guys, we'll see you in the next session then. Take care, bye bye, and thank you so much. So we'll see you in the next session of Vizag. So take care, bye bye, Shabba khair. And one more thing that I want to say: if you are new to this channel, do hit like, share, subscribe the session. And one more thing that I want to tell you: no issue, चाहत आप उसको देखो and then please let me know. But I want to tell you, उसका आंसर जो यूपीपीएससी वालों ने भी दिया होगा वो वही दिया है, रीजनरेशन. You have to see the most correct option. Remember? Okay. And my dear, I will provide the PDF. Don't worry about it. So guys, take care. Bye bye. Shabba khair. And don't forget to attend the session of Vizag at 3 p.m. So guys, we'll see you over there. So take care. Bye bye. Shabba khair. And my dear, do hit like, share, subscribe the channel. And please stay at home, stay safe, stay online with the Testbook.com.